going to kind of take a step back to be able to go a step ahead. Um, Back early on when we first started our topics, um, we solved equations and got answers like x equals 7 or 12 or 13 or -4, whatever the answer might have been. And then we solved inequalities and we got answers like the ones that I have written here. I just stuck with 7, but I changed the symbols. And we never talked about how do you graph those? Well, if you have just one variable in your solution, all you have to do is graph it on a number line. I know when we were solving systems and when we were graphing lines, we used a coordinate plane where two number lines crossed each other and made 4 quadrants. That's why we're stepping back here a little bit. We're just going to first simply talk about how do we graph equations or inequalities that have just one variable. And then we'll go back to graphing um, linear inequalities that have two variables and even systems of linear inequalities. So we'll probably do this in at least two-part videos, two different videos, or maybe even 3. In this first video, we're just going to deal with how do we graph a linear equation that we've solved and came up with an answer like x equals 7, and how do graphs of linear inequalities look different. When you solve an equation and end up with an answer like x equals 7 in the first example that I have, basically that tells us we have one answer. If I want to have a picture representation of what that answer looks like, that's where I'm going to draw my graph. Notice the graphs for all of these are number lines, open number lines. They go in both directions to infinity. Although I didn't write all the numbers that go to infinity in both directions, I just chose a few right around where my answer was. In this answer, because I only have one solution, the way I graph that and make a picture of it is I go to the answer, which happens to be 7, and I put a dot at that spot. And if you can't see that, I'll try to make it bigger. So 1 dot, x equals 7. No other numbers would have worked in whatever the original equation was. Okay, let's say that I go to graphing linear inequalities. Now you notice that for this kind of problem, the first one, it took me one kind of graph to do that. Now you notice I've got 4 different problems up here. They all have the 7 in it, just like the first one did, but the symbols are different in each and every one of these. Basically, there's 2 kinds of differences. First difference, what direction is my symbol opening? Is my symbol, or pointing maybe is better. Is my symbol pointing to the left or is my symbol pointing to the right? In your picture representation, your graph, you're going to have to be able to tell the reader. Just by looking at the graph, someone should be able to know the answer to a linear equality. They should be able to know if all of the answers are greater than or less than a certain number. And they should also be able to know if the number itself is included in the answer. So the ways that we can distinguish between these differences is by drawing drawing an arrow to indicate whether or not our solutions are smaller than a certain number or greater than a certain number, and changing the kind of circle that we put at the number, whether we use a solid closed circle like we did over here with x equal to 7, or whether or not we use a circle that's not solid and not closed in. So let's start with our first example here. It still says that our solutions are right around 7, but they're not equal to 7. So to show that 7 is not included in our solutions, I don't know how well this is going to let me do this, but I'm going to just put a 0 there. An open circle is actually what it is. I was a little bit worried about this letting me draw that because sometimes it does funny things if I hold my pen in the same spot, but we did okay there. So this open circle shows that 7 is not part of my solution set. My solution set is all the numbers that are smaller than 7 but not equal to 7. And then my arrow that I draw is what tells the reader whether or not, whoops, see that's what I was worried about, whether or not my solutions are smaller than that number or bigger than that number. Now what I like to do, because sometimes if you're using a pencil, the arrow that you draw is hard to see. People don't make this line very thick, or it blends right in with the number line. So make sure you make this really heavy if you can, and if not, then just fill in the arrow over on the end. This is supposed to be an arrowhead pointing, but it's filled in rather than open like the original ones I had. If you think that it's easier to read if you draw your solution above it, then go ahead and do that. You can draw the picture representation above the number line. You don't have to draw it right on. The only thing I'm worried about with that is making sure that you get this circle in the exact right spot. So you might even want to get a little bit closer to the number line, closer than what I did. Okay, so both of these pictures show that the solutions to this, whatever this problem started off as, are numbers that are smaller than 7 but not equal to 7. Okay, the difference in the third example, this time they're greater than 7. So they're not equal to 7, so I would still put an open circle at 7. But because the answers are greater than, my arrow would go to the right. Now I'm using a colored arrow so you can see mine pop. If yours doesn't pop when you draw yours, then just draw it above it. It doesn't have to be a long arrow either, and your number line doesn't have to be big. I only included 5 numbers on my number line. Number lines never end. If you wanted to include every number on there, you'd still be here well into your 80s drawing that number line. So just a few numbers on your number line so that I can see that you know what numbers the 7 lies in between. From this number line, I can tell that 7 is in between 6 and 8, and I even included some numbers smaller yet too, but I wouldn't have had to. Okay, now the fourth example. I know green sometimes doesn't work so well for everybody, so we'll switch to purple. The fourth example adds something a little bit different in here. I still have the less than, which is very much like my second example was, but this time I have less than or equal to, and the way I can tell that is because I've got that line underneath there. So to show the difference between example number 2, this is example 2, and example number 4, because the arrows are going to go in the same direction to show less than, this time we use a closed circle at that spot. So a closed circle at 7 indicates, yes, my answer can equal 7. The arrow shows not only can it equal 7, but it's going to be, yep, that's what I'm afraid of. It's going to be numbers that are smaller than that as well. So numbers to the left on the number line. Whenever you write your number lines too, you should always make sure that your smallest numbers are on the left and it increases to the right. Your numbers get bigger as you move to the right. Okay, now in example 5, the only difference here compared to example 3, this would be example 3, this would be example 5. The only difference between the two is that this time I need a closed circle. The graph is going to look very much the same, but my circle at 7 needs to be closed because that's what shows, hey, my answer can equal 7 too. It's not just less, or it's not just greater than 7, excuse me. And again, if you need to, you can draw that over top of the line and draw your arrow out. I'll make mine a little bigger. Okay, so that's graphing linear inequalities that use just one variable.